Hello friends, my name is Mohsin and today we are going to learn about the chapter 3, that is parallel lines. It is a very small and interesting chapter in geometry. I am sure it will be fun learning with lines. So let us see what are the parts that we are going to cover in this chapter. So I have divided the chapter in 6 parts. So in this chapter we are going to learn what are parallel lines, how to draw parallel lines, how to determine parallel lines, intercept and transversal, properties of parallel lines, division of line segments into equal parts and in given ratio. So let's begin with the first part. What are parallel lines? Now let us see what are parallel lines. So parallel line means two lines in a plane that do not intersect or meet are called parallel lines. So let us see. So this is line 1, this is line 2. Now let's name this line as line AB and line CD. Now you can see over here the two lines are not intersecting or meeting each other. Let's see. Now the symbol of parallel lines is given by two vertical lines. So we have the symbol of parallel line as two vertical lines. Now if we describe the diagram over here in terms of words, we can say that AB is parallel to CD, which is nothing but line AB is parallel to line CD. So that's the parallel line. Now, if you measure the distance between the two lines, you will find that the distance between two parallel lines are equal. So let us see that by using a divider. Now, if you keep a divider on the lines as follows, and follow the same line throughout you will find that the distance are equal. So we can say that the distance between two lines are always constant or fixed. So in other words, parallel lines are the straight lines that have a fixed or constant distance between each other. So that's about parallel lines, and you must have observed in everyday life there are parallel lines everywhere. For example, there are walls in our home which are parallel to each other. The other examples and the very best one are the railway lines. You must have seen the tracks, the lines that run parallel to each other. And the third example would be like your bookshelf. You must have seen the shelf which are parallel to each other in a cupboard. So that's all about parallel lines. Now let's move on further and see how to draw parallel lines. So let's see the properties of parallel lines and their transversal with respect to intercepts. Now there are two properties over here. Now let's see the first one. Now the first property says, if the intercepts formed by three parallel lines on any one transversal are congruent, then the intercepts they form on any other transversal are also congruent. So we have a diagram over here. Now let's see the parts of the diagram. Now in the figure, line L is parallel to line M, which is parallel to line M. So all the three lines are parallel, and line P and Q are transversal. So if intercept AB is equal or congruent to segment ABC, so in that case the intercept segment DE will also be congruent to segment EF. Now let us see using a divider. Now if we measure the distance between AB and BC, they are found to be equal. Now as the property says, if the segments or the intercepts of one transversal on the parallel lines are equal or congruent, the segments or the intercepts on the other transversal will also be equal or congruent. So let's see, AB and BC are equal or congruent. Now if we keep the dividers over here, we'll find that DE is also equal to EF. Hence it is proved. So if segment AB and BC are congruent, which means that even the segment DE and EF will be congruent. That's the property. Now let's move on to the next one. Now let's see the second properties of parallel lines and their transversal with respect to intercepts. So the second property says, the ratio of the lengths of the intercepts made by three parallel lines on one transversal and the ratio of the length of the corresponding intercepts made by the same lines on any other transversals are equal. Now let's see the figure over here. In the figure we see that line X, Y and Z are parallel to each other. So the three lines are parallel. Line P and Q are the intercepts. So we have over here line CD upon DE will be equal to line LM upon MN, which means that the ratio of the two intercepts CD upon DE and LM upon MN will be equal. So we have line CD upon line DE equals line LN upon MN. So that's the property, second property. It's a very simple one. Now let's solve the problems based on these properties. Now let's begin with exercise 12, that is on textbook page 19 and 20. Now this exercise is based on the properties that we have learned earlier. Now let's begin with the first question, which says in the figure line K, line L, line M are parallel to each other. Their transversal line C and D cut them at points XYZ and PQR respectively. So if the lengths are given, we need to find the length of QR. So let's begin. Solution. Line K, L, M are parallel to each other. Line C and D are the transversal. Now we see that all the lengths are of different length. Now let's recall the second property that we have learned. Do you remember? The ratio one, yes. The ratio of the lengths of the intercepts made by three parallel lines on one transversal and the ratio of the lengths of the corresponding intercepts made by the same lines on other transversal are equal. So according to the property of three parallel lines and their transversal, we have length xy upon length yz will be equal to length pq upon length QR. Now, substituting the values given in this equation, we have xy is 5, so we enter 5 over here, upon yz. Yz is 3. PQ. PQ is given as 5.5. And QR is question mark, that we need to find that. And now, arranging this equation, we have length QR is 5.5 into 3 upon 5. Now solving this equation, 5.5 divided by 5 is 1.1. So 1.1 into 3. Now the final answer when you multiply 1.1 into 3 is 3.3. So length QR will be 3.3. So right over here, length QR will be equal to 3.3. So that's the final answer. Simple, isn't it? Well, now let's move on to the next problem. So let's begin with exercise 12, question number 2. The question is as follows. In the figure, line A, B and C are parallel to each other. Line D and line E are the transversal and intersect them in points PQR and LMN respectively. Point Q is the midpoint of segment PR. So if QR is 7.2, LM is 6.2, we need to find PQ and length MN. So the diagram is given over here. So let's start. Solution. Point Q is the midpoint of segment PR, which is given. So midpoint means that it divides the segment into two equal parts. So since Q is the midpoint over here, which means that PQ and QR are equal. So we have length PQ is equal to length QR. Now let's take this as equation 1. Now QR is equal to 7.2, which is given. Now putting the value of QR in equation 1, we have PQ equals 7.2 since Q is the midpoint. So we have PQ, which is 7.2. Now let's recall the property of parallel lines. Since PQ and QR are equal, in other words, we can say that intercept PQ and QR are equal. So do you recall any properties? Yes, there is one. So according to the properties of three parallel lines and their transversal, we have if the intercepts formed by three parallel lines and on any one transversal are congruent, then the intercepts they form on any other transversal are also congruent. So that's the property. So we have intercept LM is equal to intercept MN. From the statement PQ is equal to QR. That is equation 1. So we have over here LM is given as 6.2. The value of LM is given, and as per the property of parallel lines, these both intercepts are equal. So LM is equal to MN. So since LM is 6.2, substituting this value in this equation, we have MN equals 6.2. So that's the answer. Simple, isn't it? And let's move on further. So let's begin with exercise 11, that is on textbook page number 16. The question is, in each of the following figures, name the intercepts, the lines that form them and the transversal on which they are formed. So the figure is given over here. So we need to find intercept, line and transversal. So let's see. Now the best way to present the answer is in tabular form in this way. You can also write the answers in terms of statements. So we'll first fill up the tables over here. Now in this figure, let's just take any one line and suppose we take line Q. So that will be the transversal, because transversal is a line that crosses the system of lines. So in order to determine the transversal, it should pass in more than 2 lines. Suppose if G is taken as transversal, so you will see that it only passes on line Q. So this cannot be transversal. So let's see. Transversal is Q over here. Now, intercept. Now just move on this line. You will see that segment DE lie on transversal Q. So I'll just write segment DE over here. Now if you look carefully over here, segment DE lies on line GH. If you extend the lines over here. So we have lines G and H. Now let's move further. Now on the same transversal Q, you see segments EF. So we have one more intercept over here, segment EF. Now, if you move this segment EF along this line, we have lines HI. So we have lines HI. Now, we have one more segments on transversal Q, that is D and F. So I'll write over here. Intercept segment DF. Now, DF, if you extend these points along the line, we find that it's G and I. So the line here is G and I. Now if you see EF lie on transversal Q, similarly DF, it also lies on transversal Q. So that's the answer. Now you can also present the answer in statement form. So if you present in statement, we have segment DE is the intercept. Segment DE is the intercept formed on lines QH. You see line Q and H over here on transversal Q. So what we've done right now is we have presented the tabular form in statement form. So segment DE is the intercept formed on lines G and H on transversal Q. So that's question number 1, figure 1. Now let's move on to the second one. So let's start with figure 2 under question number 1. So it's similar to the first question, but it is a bit complex figure over here. So in the previous question, we have seen 3 parallel lines with 1 transversal. In this case, there are 3 parallel lines and 2 transversal, or you can say multiple parallel lines. So let's see. So the table is given over here, so we need to fill in the required details. So let's see. So we'll first fill in the intercepts, then we'll go to lines and transversal. So let's see. So in the figure, we'll first focus on the line P. So I'll just mark it over here. So we'll first focus over here and mark all the segments that is given on this line P. So we see HD is one segment. Now on this line P, you see DF. So we'll write DF over here. And also you see one more segment, that is H and F. So HF. And as you have marked over here, they all fall on line P. So P is a transversal. In this case, DF lie on P is the transversal, and H and F lie on P is the transversal. Now let's focus on the intercept HD. So this is the HD. Now if you move along this line, you see that the lines are T and W. Transversal will be constant, you need not move that. Just need to focus on HD and the line on which it falls. So it's TW. So intercept HD lie on lines TW. P will be constant. We are not moving the transversal, we are just focusing on the segments, intercepts and the corresponding lines. So second one is DF. So this is constant, focus on this DF. Now if we move DF along this line, we get lines W and K. So the lines are W and K. What's the third one? HF, H and F. Now we move across this line, we see that the lines are T and K. Simple. Now let's focus on another line. So we'll remove the mark over here and focus on S. So for reference, I'm just putting a dot. You can also place your fingers while solving. So let's see this. So we'll consider S as transversal. S. And now first we'll mark all the segments, all the intercepts that we see on this line. So we see IC and we see CR, and also if you see carefully we see I and R. So all these three segments lie on transversal S. So transversal will be S, same here. So this is a constant. And now let's focus on each of the intercepts. So first IC. So this is the IC. Now if you move carefully along this line, we see that the lines are T and W. So IC are formed by lines T and W. Now I'll focus on CR. CR, if you move carefully along this line, we see that it falls on lines W and K. So CR is W and K. I hope you're understanding. Now let's focus on the last segment, that is IR on line S. So IR, if you move carefully, it falls on lines T and K. So we have over here T and K. Simple. So now we are done with P and S, and now we'll focus on T. P and S as transversal are done. So we have tried all these steps over here, all the parts that we get from P and S. Now let's focus on T. So I'll just put a mark over here, representing that we are solving T part. So T. So we have taken this T as transversal, and now let's mark all the segments that you see on this line T. So we see that HI is the only intercept on line T. So we'll just write HI as the intercept. It's the only one segment. Now if you carefully move H and I along this line, you will see that it is formed on lines P and S. So in this case we have lines P and S. T is constant, you need not move T. So let's see next. So we have done all the lines. So we just have HI on this line. So we are done. Now let's move on to the next one, W. We'll just put a reference dot over here. Now on line W, you will see segment DC. So we'll write over here DC, and it's formed on transversal W. So we have DC as segment. Now if we carefully move D and C along these lines, we get P and S. So the lines in this case are P and S. Now the last part. We move on to the last line K. So we'll just put a reference dot. So K is a transversal. Now we'll just see the segments on this line. The segments are F and R. That's a segment. Now, if you carefully move these segments F and R along this line, we get P and S. So, we have covered all the transversal, all the lines and all the intercepts in this figure. I hope you enjoyed this. It's a very simple problem, but you need to focus carefully, beginning from one line and going to other. Just need to make sure that you cover all the intercepts on particular lines. So with this, we come to end of figure 2. Now the figure number 3 needs to be solved in similar fashion. It's exactly the same. Even you see in figure 3 that there are 3 lines and 2 transversal and vice versa. So you can solve it in similar fashion. That's it. Now let's start transversal and intersect and try to understand what are they. Now in this figure you can see 3 lines, line L, line M and line T. Now in between lines L and M you see segment AB. So let's see what is transversal. A transversal is nothing but a line that intersects a system of other lines. So in this case, you can see line T, which is intersecting lines L and lines M, which is nothing but it is a transversal, is a line which passes through lines L and M. That's it. And now let's see what is intercept. Intercept is nothing but a part which is cut off by intersecting lines on a transversal. So in this case, you can see segment AB, which is cut off by lines L and M, and it is formed on transversal T. So that's called intercept. So see, it's very simple. Transversal passes through lines L and M, and intercept is formed on lines L and M on transversal T. So that's it. Now let's see how to draw parallel lines. So the question is to draw a line parallel to a given line through a point outside the given line. So in this case, let's see line L, and there is a point P outside the line L. So you need to draw a line that is parallel to line L passing through point P. So let us see. So for this you will require a ruler and a set square. So this is a ruler and this is a set square. So we'll first place the set square in such a way that the edge of the set square lie on line L. So you can see over here the edge of the set square lies on line L. Now just place it carefully. Now place the ruler on the other edge of the set square. So it's fixed. Now you need not move the ruler. So you can see over here the set square is free to move. The ruler should be fixed. And now just carefully move the set square upwards in such a way that the edge of the set square lies on point P. Now carefully place a dot over here. Now you can remove the ruler and the set square. Now you can see you have 2 points over here, and you know that while joining two points you get a straight line. And now you're free to draw a line. So if you join the two dots, you'll get a straight line. Now let's name this line as line M. So you got a straight line over here. And now let us see if the two lines are parallel to each other. So for that, we'll require a divider. So carefully place the divider on line L and the other on line M. Now you can slide the divider on these lines. You can see that the distance between the two lines are equal. So we know that in case of parallel lines, the distance between the two lines are always fixed. So there we have two parallel lines L and M. Simple. So let's move forward. Now let us check if the two given lines are parallel or not using ruler and set square. So we have two diagrams over here. In the first you see line L and line N. In the other figure you see line E and line D. Let us see if the two lines are parallel or not. So let's go with the first figure. So in this case we'll use the set square and ruler method. So place the set square in such a way that the edge of the set square lie on line L. And now place the ruler on the other edge. Now fix the ruler, do not move it. Now carefully slide the set square upwards in such a way that the edge of the set square lie on line N. Now you see over here that the edges are lying on line N perfectly. In other words, it is coinciding. So you can see that line L is parallel to line N. Now let's see other figure, line E and line D. So same way, we'll first place the set square in such a way that the edge of the set square lie on line E. Carefully place the ruler. Remember, do not move the ruler. Now slide the set square upwards and see that if it's lying on line D perfectly. So in this case you can see that the edges are not coinciding with line D. See? So in this case you can see that line E is not parallel to line D. So friends, so in this case we can determine whether a line is parallel or not. So let's move further. Now let us study about the properties of parallel line. So we have two small properties over here. So let's go with the first one. So the first property says the lines parallel to the same line are parallel to each other. So in this figure you can see three lines, L, line M and line N. Now if line L is parallel to line M and line L is parallel to line M, so in this case the line M will be parallel to line N. So let's see, is the same ruler and set square method. So place the set square on line L. So the edge should be fixed on line L. Now place the ruler on the other edge. Now carefully slide the set square on line M, first line. You can see that the edges coincide. Now move the set square downwards on line L. You'll also see that the set square coincide on line N. So you can say that all the three lines are parallel to each other. So in this case, if line L is parallel to line M and line N is parallel to line M, which means that line M is also parallel to line M. So that's the property. Now let's move on to the next property. So the other property says the lines perpendicular to the same line are parallel to each other. So in this figure you can see line M. You can see that line M is perpendicular to line L and line N is perpendicular to line L. So in this case, if M is perpendicular to line L and N is also perpendicular to line L, the same line, you'll find that lines M and N are parallel to each other. So let us compare the same using the set square and ruler method. So keep the set square on this edge on line M carefully. So this edge coincides on line M. Now place the ruler over here and now carefully slide the set square in such a way that the edge coincides on line N. So you'll find that the edge of the set square coincides on line N. So we can say that both the lines M and N are parallel to each other. So there's the property. So we have learned two small properties over here. So let's move on further. So now let's start with exercise 13, that is on page number 22. So the first question is divide segment LM of length 9 cm into 5 congruent parts. Congruent means equal. So we need to divide segment LM into 5 parts. So I've drawn over here segment LM which is of 9 cm. So let's try to divide it into 5 equal parts. So in this case you will require a D, a protractor, rounder, scale. Now the first step is to use the protractor and draw an angle. So in this case we'll take angle 30 degrees. So the point to remember over here is that the angle should not be more than 45 or not less than 30. So the best option is 30 for knee diagram. So you have drawn an angle 30 over here, placing on point L. Similarly, we'll draw an angle on other side, placing on point M. (30°). So we have drawn two angles on other sides. Now let us join the points. So we'll get straight line. The same on the other side. And now let's divide it. Now we know that 9 divided by 5 is 1.8 centimeters. So let's see the rough work. So 9 divided by 5 is 1.8 centimeter. So each part on line L, M will be 1.8 centimeters. So in this case, we need to mark the arcs on line L and line M. So we'll take, for easier purpose, 2 centimeters. So we'll mark the arcs 1, 2, 3, 4, and 5. Since we require 5 points. Similarly, we'll mark the arcs on line M. 3, last 2 points, 4 and 5. So we have drawn 5 arcs on both the lines. So let's name them. This will be L1, L2, L3, L4 and L5. Similarly over here, M1, M2, M3, M4 and M5, and both the angles are of equal distance of the same measurement. And now let us join the lines. So point L and the last point on line M. Similarly, we'll join all the other points. So be careful while joining the points. It should be exactly coinciding the points that you have taken. So there you go. So you see that the line LM is divided into 5 equal parts. So let's name the segments A, B, C and D. So you see that LA, AB, BC, CD and DM are the 5 equal parts of segment LM. So you can also write over here the final answer in words. Segment LM is divided into segment LA, segment AB, segment BC, segment CD and segment DM. So that's it. That's the first question. Let's move on. So now let's move on to the fourth sum under exercise 13. So the question is, divide segment ST of length 10 cm in the ratio 2:3. So you'll see it's much similar to the first one, but in this case the ratio is given. So let's start. Now, as you have solved in the question number 3, the ratio, while adding the two numbers, we will get the part. That is 2 plus 3 is 5. So segment ST must be divided into 5 equal parts. So we have over here segment ST I have drawn, which is of 10 cm. Now let's divide it into 5 parts. So beginning with the protractor, we'll draw an angle. You can draw any angle. So in this case, let's take 30 degrees. Mark a point and just draw a line over here. And now let's name this line as SX. So it's line SX. And now similarly, we'll draw the angle on other side. So we'll keep the point on T and draw the same angle of 30 degrees over here. Now we'll join the 2 points. We'll get a straight line. So we'll just name this line as Y. So it's line TY, and these both angles are same. And now we know that segment ST is of 10 centimeters and we need to divide it into 5 equal parts. So dividing 10 by 5, we have the answer as 2. So you can draw the arcs on this line by taking the measurement as 2 centimeters. So we'll draw the arcs over here. First we'll start with segment or line SX. So we need to divide into 5 parts. So we'll mark 5 arcs on line SX. Carefully. 1, 2, 3, 4 and 5. Similarly, keeping the same distance on the rounder, we'll mark the arcs on line TY. We need 5 parts, so we'll draw 5 arcs. 1, 2, 3, 4 and 5. Now let's name these points. So in line SX, we'll name the points as S1, S2, S3, S4 and S5. On line TY, we'll name the points as T1, T2, T3, T4 and T5. And now let us join the points. So we'll start from over here, point S and T5. So carefully join the lines, join the points, sorry. Now I'll move on to point S1 and T4. Similarly S2 and T3. S3, T2. Points S4 and T1. And finally point S5 and T. So we have successfully joined all the points. Now let us see carefully. You can see over here there are 5 equal parts. 1, 2, 3, 4 and 5. Now in the question we need to divide the segment ST into ratio 2:3. So we'll just count 2 parts over here. This is the part 1, this is the part 2. Now let's name the point as P. So you can see that these are 2 parts and the remaining will be 3 parts because 2 plus 3 is 5. So we have 3 parts over here. So you can name the parts. SP has 2 parts while P and T has 3 parts. So finally you can show the answer in statement form as point P divides segment ST in the ratio 2:3, that is length SP is to length PT equals 2:3. So that's your final answer. So friends, it's very simple. Just make sure that you make the lines carefully, joining the points. So now if you see carefully, the next 3 questions, that is 5, 6, 7 is similar to the same one, the question number 4 that we have done. So with this we come to the end of the chapter. I hope you enjoyed it. Wish you all the best. So let's move on to further. So let's continue with exercise 13, page 22. So the second sum is similar to the first one that we have constructed. So let's move on to the third one. Now in this case, a tabular format is given in which the ratio of division of line segment is given on the top, and we need to find the number of congruent parts of line segment. So the questions are 2:3, 1:5, 1:2, 3:4 and 5:3. So the ratio is given and we need to find the congruent parts. So it's very simple. You just need to add the 2 numbers. So 2 plus 3 is 5. So the answer will be 5. Now 1:5. So just add the 2 numbers. So 1 plus 5 is 6. Now here 1:2. While adding, we'll get the answer as 3. Similarly 3 plus 4, 7. 5 plus 3, 8. So friends, it's very simple. There is no much calculation in this case. So let's carry on. So now let's move on to the fourth sum under exercise 13. So the question is, divide segment ST of length 10 cm in the ratio 2:3. So you'll see it's much similar to the first one, but in this case the ratio is given. So let's start. Now As you have solved in the question number 3, the ratio, while adding the two numbers, we get the part. That is 2 plus 3 is 5. So, segment ST must be divided into 5 equal parts. So, we have over here, segment ST I have drawn, which is of 10 centimeter. Now, let's divide it into 5 parts. So, beginning with the protractor, we'll draw an angle. You can draw any angle. So, in this case, let's take 30 degrees. Mark a point. And just draw a line over here. And now let's name this line as SX. So it's line SX. And now similarly, we'll draw the angle on other side. So we'll keep the point on T and draw the same angle of 30 degrees over here. Now we'll join the 2 points. We'll get a straight line. So we just name this line as Y. So it's line TY. And these both angles are same. And now we know that segment ST is of 10 centimeters and we need to divide it into 5 equal parts. So dividing 10 by 5, we have the answer as 2. So you can draw the arcs on this line by taking the measurement as 2 centimeters. So we'll draw the arcs over here. First we'll start with segment or line SX. So we need to divide into 5 parts. So we'll mark 5 arcs on line SX. Carefully. 1, 2, 3, 4, and 5. Similarly, keeping the same distance from the rounder, we'll mark the arcs on line TY. We need 5 parts, so we'll draw 5 arcs. 1, 2, 3, 4, and 5. Now let's name these points. So in line SX, we'll name the points as S1, S2, S3, S4 and S5. On line TY, we'll name the points as T1, T2, T3, T4 and T5. And now let us join the points. So we'll start from over here, point S and T5. So carefully join the lines, join the points, sorry. Now I'll move on to point S1 and T4. Similarly S2 and T3. S3, T2. Points S4 and T1. And finally, point S5 and T. So we have successfully joined all the points. Now let us see carefully. You can see over here, there are 5 equal parts. 1, 2, 3, 4 and 5. Now in the question, we need to divide the segment ST into ratio 2:3. So we'll just count 2 parts over here. This is the part 1, this is the part 2. Now let's name the point as P. So you can see that these are 2 parts and the remaining will be 3 parts because 2 plus 3 is 5. So we have 3 parts over here. So you can name the parts. SP has 2 parts while P and T has 3 parts. So finally you can show the answer in statement form as point P divides segment ST in the ratio 2:3, that is length SP is to length PT equals 2:3. So that's your final answer. So friends, it's very simple. Just make sure that you make the lines carefully, joining the points. So now if you see carefully, the next three questions, that is 5, 6, 7, is similar to the same one, the question number 4 that we have done. So with this, we come to the end of the chapter. I hope you enjoyed it. Wish you all the best.